Hi and welcome to the next video in our beginner tutorial series on how to create your first DirectX 12 application in C++ from scratch. During the last episode, we created a simple toon shader that takes a material color and uses a global directional lights and calculates how the color should be on the object depending on its position in relation to the lights. It's a really simple shader program, but it works. Um, uh, in this episode, we will be creating so-called transform matrices. So-called transform matrices. Sorry, my headset is really bad. It just falls out occasionally. um, that describe how different objects are rotated, scaled, and translated. And usually an object has a unique transform in terms of describing its placement in the world. It also means that you can use the same meshes multiple times by simply just creating separate matrices that contain the rotation, scaling, and position of the actual object in 3D space. So we would like to be able to upload this information to our GPU. We want to do it on a draw call basis. Maybe not upload it per se, but at least be able to access it on a draw call basis. Therefore, we want to create a struct that we can upload to a upload heap, which will contain our object data. This will be a so-called per object kind of buffer, and it will contain a XM matrix actually called its transform matrix. And we will set this to be initialized as an identity matrix, meaning that the vertices themselves are not rotated, are not scaled, and are not translated in terms of their position in object space. This matrix here simply controls every attribute of the object. It can also create skewed objects if you want to. So it's a really nice data structure to be able to bind to your pipeline. As for our pipeline here, we want to bind it to the root signature, since we will be using our root signature arguments as a way to couple the transform matrix to each draw call. Since you should order your root parameters here in the order that they are updated, starting with the most regularly updated data structure. You should try to arrange them in such a way that that is upheld. So this is the past data. It's updated each frame, since the camera and everything else might change. So therefore, we need to update it each frame. Then we would like to be able to update the transform matrices. Secondly, because sometimes our objects move and therefore sometimes their transforms change. And then lastly, we want the materials bound because they are probably not changing. So therefore, they will be more rarely updated, and therefore they should be placed as the last argument of the actual root signature. So we will rearrange our root signature here, and our transform will be available to the pixel shader here, or rather vertex shader, because it will translate the vertices themselves. I'm pretty sure that we don't want to use the transform matrix inside the pixel shader. Usually I don't do that. But there might be a case where you want to upload it to your other shaders. Let's see. But now we change the order of the material and the pass data, structure. Our render API here will, the view projection matrix is something that, okay, we have vertex buffers, index buffers, materials, pass data buffers, and lights. These are kind of like scene resources. So let's rearrange them. And let's create a vector of the 12 resources that we call our transforms. Let's call them object transforms. And we want to create object transforms. You kind of know the drill here. We will and place back a empty D12 resource here. And then let's see, we could be lazy and well, this doesn't actually return a reference. Okay. And then we want to access our transforms here by taking the latest object inside of it. And then we want to initialize that using our device. We want to create it with the size of our let's see, object data here. Let's see, that's the right structure. Yeah. And we want to create it on the upload heap. And we want to create it in the generic read state, which is usually what we do for our dynamically stored buffers. So we initialize it, and then let's see. We initialize it, and then we want to access it, or rather, no, we don't want to access it. We just want to memcopy some values over to it. So we will get the CPU address. Right now, we will create a null pointer, and we will write our object data. Let's just do a temp data here. Right now it will be an identity matrix. We're just gonna oh, wait a minute, I forgot that inside our root signature we of course need to create update our registers as well. There we go. We have updated our registers. Let's the pass data is still the same. The material data is now B2. Okay. Okay, we copy the data, and now we want to bind it to our pipeline. We simply grab this. We know that it's the first one that we're using right now. We will, of course, set the parameter here to 1, and let's do like this. So this should be fine. Okay. We of course need to include the vector here. Engine minimum. Well, okay. We could also do just the PCH. Does it contain vector? No, it doesn't. That's interesting. Usually I include vector as some of the first structs, or rather standard library functions. Yeah, okay, everything compiles. So now we need to bind our vertex shader to our data structure here. We will have a struct called object data, which will contain a float 4x4 called transform. And we of course want to bind that to our pipeline here. Let's see, we do object data here, and we bind the register here. There we go. And we need to apply our transform here to every vertex. So we will create a temporary position, which we will call world position, which will be our let's see, we will do our world position, which will initially take our original position, and then we will update it by multiplying our object data transform with our world position. And then let's see, we of course need to add an extra 1 here to the end because it's only 3 floats. And we will instead use that. Let's just comment this out and change this so that we instead use the now translated world position instead of our original position here. And we will of course grab the RGB here, or XYZ, maybe that's more obvious what we're actually doing. The normal position actually also needs to be translated by the object data transform, because if the object is rotated, so are the normals. So therefore we need to update the normals here the same way, and we since we pass along a float free, we do XYZ here as well. Okay. Right now this shouldn't change anything because we haven't done anything to our transform, but under the hood everything now changed. Not everything, but some of it changed because now we can set our temp data transform here, the first register, maybe we want to set that to something like, well, maybe we want extra scaling on the x-axis. Let's try that. I've been doing a lot of different stuff in terms of register handling. Oh, wow. Would you look at that? We did X scaling. So that's great. I'm sorry about that. And as you can see, we simply now have a scaled object. We can change the Y scaling as well. There we go. We can also change the X position. I think it's stored here, but I'm not sure. Nope, it's not. The X position is then stored inside this. Okay, this is the Y position. Now it will move upwards. Yeah, as you can see. Let's try doing like this, and then maybe a bit out to the side here. Okay, that doesn't look pretty. Let's not do that. And of course, we can change different attributes. Did it get more visibly lit? Let's just zoom out a bit here. Maybe do 8 and 8 here. Okay. Anyway, you can do all sorts of different transformations. Whoops. And yeah. Now we can do several instances of these. Let me show you. So let's just change our system here in terms of the material buffers. We will also do a vector of those. We will need to handle that. In place back a D12 resource. And we will simply do this totally manual like this, and initialize as before. I change this. And then we will of course also upload it. Let's create a scoped section here where we simply do material allocations. Let's do another material here where we set it to material number 2, and let's do a blue material. There we go. And of course we need to set that material to that address. Okay. And down here we need to set the appropriate material buffer here, and everything should still work. But now we have oh, wait a minute, we have an error somewhere. There we go. Redefinition. Oh, there we go. Now we can do multiple objects, but we first need to do this as well, preferably in a scope. Transform allocations here, and let's instead just do manual indexing here because it's a bit more nice. We will create a object with excuse me an identity matrix. Let's set the temp data transform last register to something like, well, we want a world space position -2, no, -3 on the x, well, still at the 0 on the y, and then maybe -2 on the z axis. And the last component can just be 0 here. Okay, so now we have created 2 transforms. We have created 2 materials. Let's do 2 draw calls. Right now we do a single draw call here. Draw call. Let's group it together. And let's do another draw call here, where we simply swap these and draw with a different transform and a different material. As you can see, the objects now have different positioning and different materials. All right. So now we have created support for transforms, materials, draw calls. Even though they're not instanced, you could optimize that and batch these together, but you would have to find another way of controlling their materials and their transforms. But yeah, basically you now have a application that can draw a lot of different stuff. We could do some scaling here on this object here. Let's try that. Maybe we wanted to scale it really small on the x-axis, and maybe give it a bit of a skew on the other axis. So let's try that. As you can see, the object now looks different. This wasn't intentional, but yeah. And if you want to rotate it, you can also do that. We could, let's see, okay, when we close the application, we end up in a situation where we're not behaving as nicely. Okay, the shader. Okay, let's do some cleanup here. As we've been neglecting that. I don't think we should be able to reach a state where the bytecode was 0. Hmm. I mean, okay, but let's go through our resource deallocation here. These buffers should auto deallocate. Let's see if they are mapped. We unmap. We reset. Okay. I'll consider it. Okay, this might relate to the vector handling here. Okay, we will do the cleanup step, and then we are actually mostly done with our series so far. I list in the material buffer size. Let's do that. Then we do the object transforms and release those. Let's see. Okay, now we're good. Great stuff. No problems. Okay, let's see, where else do we need to release? We need to release the index buffer. Yeah, we've been neglecting doing that. It probably wouldn't matter, but we like to have some proper control over our application. Let's see. Let's release the index buffer as well. How far have we gotten in terms of removing stuff? Oh yeah, the pipeline state, base pipeline state. It should release everything. And then we have a series of resources. Oh yeah, we of course need to release our buffer uploader. Release. Great stuff. And then we want our descriptor heap. That's the DSV. Release that. Let's see, do we have any more resources? Okay. It doesn't like when I okay, maybe I just yeah, maybe it's not even allocated. Let's first of all flush the command queue so that nothing is referenced. And then we have a couple of resources that we haven't released. We have the pass data. Do we release that? No, we don't. twice actually. Let's see. All right, we have only one resource left. Okay, this might be pertaining to the vector. Yeah, that's a known bug. We need to implement a move and copy method on the resource. It will only be problematic when the application shuts down or if the buffers resize. Let's see, do we have anything else that we need to release? Maybe the depth buffer itself. And I think we're done. And let's see. Okay, we get that error, and we do get it no matter what I expect. No? Only when closing? Yeah. Well, it didn't complain this time. Let's see in our resource here if we can figure out the bug. On the destructor. Oh, wait a minute. Of course, we want to unmap here, and then we want to set that to a null pointer. That's a bug. All right. Well, all right. So this actually calls let's try stepping through. All right. All right. It accidentally stepped into something. Okay. So we now found the error. So it's during the okay. Let's see. We want to know which object it is. So let's get the application up and running. Blah blah blah. We don't care. Blah blah blah. Continue. Okay. Now let's close it. Okay. So this should be 0, meaning that we shouldn't unmap. Hello. I will implement that in my other series in my own game engine. That's a fairly complex um, problem that you uh, need to solve. You need bounding volumes, and you need ray casting and intersection testing for that. So, but if you watch my other streaming series, I actually, when I refactored the renderer, I end up doing that. All right. So watch this. Let's see. Okay. So right now we do not have the problem. We are not releasing anything. Okay, now we're stepping into the object transforms, and we actually get an error here. Is it because I've never actually set the get CPU memory? Okay. So whenever we release that specific object, we get into trouble. Is it the same thing every time? Let's see. Yeah, it is. Let's also name the resources so that we don't have to guess. So we name this resource. Oops. Set name. Transform 1 CB. Yeah. And then transform 2 CB. And we will know which object causes the error. Transform 1 CB. This sub-resource 0 is not mapped. Huh. It's not a critical bug since it happens on resource deallocation, but yeah, I don't think it's supposed to do that because the only thing I can think of is a custom copy constructor being called on the object, and the pointer being in a different state. Because I think if you watch closely here, if I take the vector and if I reserve 2 slots, which means it will not resize ever, it will just keep the same allocation size. No copy or move constructor will be called on any of these objects, and therefore their states will be exactly as we see them here. If we close this, yeah, now we don't get an error. So it's because of the custom copy/move constructor, um, or rather the default move constructor. So we need to implement that in our resource here. Implement move/copy constructor for objects, since we store it in vectors and they resize. It probably just copies over this value, but it's never actually mapped. So we want control over how this information is transferred whenever the vectors resize. Right now this won't bug, but it's certainly something that needs a more viable long-term fix. But yeah, I think that's it for this episode. I'll be doing a break, I think. Are there any questions to the current episode in terms of transforms? Let's try toying around with the lights while people decide if they have questions. Thank you. Let's set up the lights here. Maybe we want a different light direction. Maybe maybe we just want a light that shines down on these boxes. Well, that definitely didn't work and do anything interesting. Now that looks a bit more interesting, right? Let's zoom in with the camera here. Yeah. Maybe we will do shadows. Let's do a scene floor here, just to be complete, to show the real power of our system here. So we create our material buffers. We reserve a size of 3. And yeah, you could do that, but I mean, it's basically manipulating this view projection matrix. So it's just it's not an difficult topic. You just change the position of the camera here. You manipulate this vector here. So since this is not a series on actually how to implement controls and everything like that, but it's directly focused on the renderer part. I think even though we could do it, people can figure most of that stuff out themselves, I think. Oh, okay. Uh, well, just be mindful if you're using DirectX math, and that look at is a one version of the way to generate a view matrix. The other version is XM matrix. Perspective lift. No. What is it called? Look to, look at. Yeah, look to, I think. Look to, and you specify the camera position, the eye direction, and the up direction. This one is fairly easy to manipulate, since when you use this one instead and you change the position vector, everything just updates perfectly. The reason why this one is hard to control is because you're constantly looking at a specific point, and the math that revolves around that one is different. So if you want something like a strafe camera that you can update by using WASD or something, you shouldn't be using this one. You should instead use this one and define a forward-going vector. So you would do something like the vec3 position, the vec3 normalized forward direction, and then the vec3 normalized up direction instead, and you would simply just update this every frame. You could also rotate that in 3D space, and the camera would adjust. You could also update the forward going. Because the forward going vector, if you change this one and or the up direction while keeping the same position, it's basically yaw and pitch. So if you rotate this, you basically end up, if the camera is not pitched, you rotate around the y-axis, and this rotates around either, no, this actually rotates around the x-axis. Yeah. If you look into the math behind it, it probably gets more clear what you need to do. It's a fine suggestion, but yeah. I have a episode on doing a camera controller on the other streaming series, so I would refer to that, since no problem. But I'll definitely consider doing the shadows now that you've mentioned it. That's a bit more interesting topic, and it also is within the scope of actually doing a simple application that has lights, materials, and yeah, shadows. So we could definitely do that. Let's just add one material here. Let's call it floor, and set that to a gray color, dark gray color here. Upload that, and then let's upload this let's see, any other suggestions, comments, or anything while I wrap this up? XM identity matrix. Let's see, transform. Let's reset that one, and 10, 3, floor. Okay, let's see, we will do a draw call here. Draw a floor. And we will bind this, and we will, of course, create a floor-like data structure here. So our position is supposed to be offset downwards on the y-axis, but otherwise just dead center. So we maybe do 4 down on the y, and the rest is going to be like this. And the scaling on the XYZ will be fairly big. So let's do scaling here. Let's do 100 in terms of scaling. And the last one. All right. Okay, it didn't work out totally as I expect. It didn't work out as I expected. Let's see. Did we create that? Maybe let's see if I just created. Okay, and let's check the color here. Haven't I? Huh. Okay, let's see what happens when we run it through direct our NVIDIA Insight here. I'm probably getting a bit tired and missing some stuff. Oops. Probably need to update some shaders or something. Let's try doing that at least. Oops. It's better. Did I not capture a frame? I did now. Okay. Yeah, yeah. It's usually related to the math when you don't see things correctly. Maybe, oh, maybe I need to change this. Load 3, right? Load 4. Well, that's supposed to be fine. Let's do our draw calls here. The last one, the geometry here. Well, it's the same geometry, of course, but okay. For some reason, it doesn't like something that we do. It's probably related to, yeah, I don't know. Let's do 10. Oh, okay. Maybe we're just, I'm so stupid. Now I know why it wasn't showing me us anything. It's because um, we were actually scaling it so large that it was, we were inside it. And of course, we only need to scale it on the X and Z plane. We actually want to scale it down in terms of the Y, and then we want to move it downwards on the Y. There we go. Now we have a plane of sorts here. Let's see. Yeah, you can use that. It depends on the type of camera you have. But let's move this camera a bit away. Okay. Yeah, this sets us up for doing maybe shadows if we want to. Anyway, I think this is it for this episode. I will be rounding out the video. Uh, yeah, I think everything is working as it should. And yeah, hopefully you found this helpful, inspirational, or just entertaining. Yeah, it's been a fun little project to do on the side of things. But yeah, I definitely also want to be working on my primary project. I'll consider doing the shadows as a separate episode here uh, in this series, and then I'll probably consider everything somewhat done. But we'll see. Maybe if there are a large number of requests in terms of simple topics, I'll add them. But please bear in mind that most topics in terms of doing everything from scratch is somewhat complicated, and even though it seems like a simple feature, it might require several additional components. Also, I might already have done it in my other streaming series, so feel free to browse through those episodes and see if there's something that you can use in that regard. I try to title things as appropriate as possible. Anyway, I hope you feel like liking, commenting, or subscribing, or perhaps even like supporting the channel. Either way, thanks for dropping by, and hopefully I'll see you around.